This is R.D. Sharma solution. We are taking exercise 17.2 of chapter number 17, increasing and decreasing functions. Now prove that the following function is increasing on R. Now there are certain additions where this question you will not be able to find. There are other questions also which are added somewhere they are not there. So the basic questions and the idea remains the same. We have fx, so we will take the differentiation. It will be 15 x raised 4 plus 14 to 3 is 120 x square and then 240 here. Now take 15 common because I can see 120 and 240 they both are divisible by 15. So you can take 15 outside. Inside you will get 8 raised 4 plus 8x square plus 16. Now if I tell you that this is a square, just take x square plus 4 and square it. It will be x square plus 16 plus 2 into 4 into x square. So this is x square plus 8x square plus 16. So you can write it as x square plus 4 whole square. Now the logic is clear. 15 is a constant, so no problem with positive, negative. Anything square, you take anything. If you take negative square or plus square, you will always get anything of the even power will always be positive. So this will always be positive, that is f dash x will be greater than 0. So this is how we are going to write, and this is a very straightforward question. And the questions which are coming like this, they also have the same logic. So I will just show you how it is to be done, because it is similar to the previous question. You just have to make it as a perfect square. So 2x minus 3 whole square will always be positive because it is square. And 3 is a constant, so this function is increasing on this real number r. Positive into positive will always be positive. That tells f dash x is greater than 0. Now prove that the function f given by fx equals to log cos x is strictly increasing on negative pi by 2 and strictly decreasing on pi by 2. See, f dash x greater than 0 is increasing, is strictly increasing, and greater than equal to is increasing. So this equality sign will make it as just increasing. If you remove that, that will be strictly. So f dash x will be, I am just taking the differentiation 1 by cos x, and cos x will be sin x minus sin x. So it will be negative 10x. Now in between negative pi by 2 and 0, this is strictly increasing and decreasing, strictly decreasing in 0 to pi by 2. Now this make this quadrant figure and mark wherever the sine, cos, tan are positive or negative. So add sugar to coffee. All sine, tan, cos. So all are positive in the first quadrant, and wherever you find out the letter, those letter matching with the trigonometry name, they will be positive. So x is between which two values? X is belonging to negative pi by 2 and 0. So this is pi by 2. This is the mirror opposite. So it is negative pi by 2. So minus pi by 2 to 0 is actually the fourth quadrant. What will be the tan x? Since only cos is positive, it is going to be less than 0. Now multiply both sides by negative 1. When you multiply by negative 1, this less than sign will change to greater than sign. So minus tan x is greater than 0. This is your fx, which is greater than 0. That is between negative pi by 2 and 0. It is strictly increasing. Next one is x belongs to 0 to pi by 2. So we are talking about the first quadrant. All are positive. So tan x will also be positive. Now multiply both sides by negative 1. So the inequality will change. Minus tan x will be, as I multiplied by negative, I am changing the angle sign. That is the inequality sign. Minus tan x is, this is f dash x, which is less than 0. So between 0 and pi by 2, it is decreasing, strictly decreasing actually. It is not less than equal to, so strict. Now this is how we are going to write. So this diagram of add sugar to coffee will immensely help. The examiner will also learn that you learned it, and now you are able to solve the question in light of that knowledge of add sugar to coffee. Prove that the function this is given by, so strictly increasing on r. F dash x should be greater than 0. We are talking about real number. So again, very straightforward question. Just take the differentiation here. This will be 3x square minus, this is 6x and this is 4. You can take this first term. We are manipulating it so that we can show it that it will always be positive. So if you take 3 common from here, it will be x square minus 2x, and this will be 4. X square minus 2x, I can make it as a perfect square. X minus 1 whole square is what? X square plus 1 minus 2x. So this x square plus 1 minus 2x. So 1 is not there. So when you add a 1, 3 will be added actually, because 3 is already outside, so you have to subtract 3 in order to keep the equilibrium. So if I have added 3, I have to subtract 3. This is what? This is x minus 1 whole square. This is 3 plus 4 minus 3 is 1. 3 is a constant, 1 is a constant. How about x minus 1 whole square? This will always be positive because it is square. So this function will always be greater than 0, strictly increasing. Now how you are going to write about it? These are the ways you can write. Prove that the function fx equals to cos x is strictly decreasing in 0 pi, strictly increasing in pi to pi, neither increasing nor decreasing in 0 to 2 pi. So whatever you have learned up till now or completed question, this question is also based on that. First, this is add sugar to coffee. That means in first quadrant all will be positive, others sine, tan, cos respectively in the quadrants. First we are taking f dash x, I am taking the differentiation, it is negative sine x. Now when we have this negative sine x in 0 to pi, this is 0 to pi. Now all are positive here. Sine x will be positive here. It will be greater than 0. Multiply both sides by negative 1. It will be minus sine x, which is less than 0 because the inequality will change. So minus sine x less than 0, that is f dash x less than 0, that is it is strictly decreasing in 0 to pi. Now coming to the second part, pi to 2 pi we are talking. So this is pi, this is pi. So 0, pi by 2, pi, 3 pi by 2 and then 2 pi. So we are going from pi to 2 pi, that is third and fourth quadrant. Third and fourth quadrant we are talking about. In the third and fourth quadrant only tan and cos are positive. It will be, this sine will be negative here. It will be negative. So sine x will be, see it is less than 0 in pi and 2 pi. That is very important. Multiply both sides by negative 1, you will get minus sine x. This is greater than 0 because you have multiplied both sides by negative 1. So f dash x is greater than 0. So it is between pi and 2 pi. So this is increasing now. So when you combine these two, that is 0 to pi and pi by 2, if it is combined from 0 to 2 pi, from negative infinity to infinity, I am talking about an imaginary line. If this is 0, this is pi, 0 pi and 2 pi, because pi is simply 22 by 7. So you can mark it, and to explain, you can just find it out that whether we are talking about any number which is higher or lower. So 0 to pi, this function is actually decreasing, and between pi and 2 pi, this function, as we have already explained, that it is greater than 0 or increasing. So between 0 and 2 pi, which is the combined interval of 0 to pi to 2 pi, in this combined interval, this is somewhere increasing, somewhere decreasing. So it is neither increasing nor decreasing. So this is how we are going to do this. These are three parts. So first differentiate, and on the basis of differentiation and the intervals, just try to explain how you are going to solve this. These are the way. And please remember that diagram should be very helpful. Show that fx equals to x square minus x sin x is an increasing function on 0 to pi by 2. So we need to differentiate it first. Let us differentiate it. So this is f dash x. This will be, x square will be 2x. And x sin x will be what? X cos x plus sin x. So I have applied the product rule here. 2x minus x cos x minus sin x. This is f dash x. Coming to add sugar to coffee again, 0 to pi by 2 we are talking about. That is, in all the terms in 0 to pi by 2 they are positive. So if you take sin and cos, it is the value is between 0 to pi by 2. These are the two, you can say, interval or boundary. So sin 0 is 0, sin pi by 2 is 1. So sin is between 0 and 1. How about cos 0? Cos pi by 2? It is between 1 and 0. So you can see it is between 1 and 0, 1 and 0. Alright, so you have x, if it is between 0 and pi by 2, sin x is between 0 and 1. Cos x is what? Cos x is also between 0 and 1. I told you 0 and pi by 2 are the interval. So when we have sin x and cos x, both are positive, and you are going to put any value of x which is between 0 and pi by 2, which is again positive. So 2 into positive minus positive into positive minus positive is going to be what? It will be, so this x is also between 0 to pi by 2. And please remember, this cos x and sin x will always be between 0 and 1, not because actual range of cos x and sin x is negative 1 to 1. But here between 0 and pi by 2, if you put all this value, f dash x should be greater than 0. Only between 0 and pi by 2 I am talking about. So we can strictly say that this is going to be greater than 0, as we observe and as the value of 6 sin and cos vary. Now how are we going to solve it? So this is, writing is very important, which I explained you. Find the values of a for which this fx equals to x cube minus ax is an increasing function on R. So this is a very simple question. You just differentiate it. I am taking f dash x, which is differentiation of this is 3x square minus a. Now you have to show that it is an increasing function on R. So f dash x should be greater than 0. That is 3x square minus a should be greater than 0, increasing. Greater than equal because it is Strictly increasing is always greater than 0. Normal increasing is greater than equal to 0. So when we take this inequality, a is coming less than equal to 3x square. Now you tell me what will be the minimum value of x, because when you're taking a less than equal to 3x square, tell me what will be the lowest value of x square, because 3 is a constant, x can vary any value, these are the real number, and since we are talking not about x can take any number, but x square can take only positive number, so it will always be positive. And what is the lowest number which you can have? 0. Okay, so a less than equal to 3 into 0, so a should be less than equal to 0. I'm saying that we are talking about real numbers. Then we square the real number. Real number squared means all positive number, means 0 to infinity, any number can be there. So what is the lowest number possible in this x square, which is 0. So I use the lowest number in x square, which is 0. So 3 into 0 is 0. So a should be less than equal to 0. This is the whole logic. This function will be increasing in this case, less than equal to 0. So this is how are we going to write. So there are questions where various questions have already come in the examination. So you need to be very careful while solving them. Find the values of b for which the function fx equals to sin x minus bx plus c is decreasing on R. So we'll just differentiate this f dash x. Sin x is cos x minus b, and this is 0. So cos x minus b is decreasing. So cos x f dash x should be less than 0. That means cos x minus b less than 0. Cos x should be less than b. But we need certain value. We cannot just say that, oh, b should be having this relationship with cos x. Now cos x will be between what? Cos x can be between -1 and 1. Since b is greater than cos x can be between -1 and 1. So just tell me what will be the value of b, because b is greater than cos x. Highest value of cos x is what? It's 1. What is the lowest value? -1. So you have to use a value of cos x, which I just told you, between -1 and 1. So there has to be some value which has to be put it here. Cos x, again I am reiterating, minimum is -1. Cos can only produce -1. Cos can only produce highest as 1. So this is decreasing. So I am just using equal to, just to re-emphasize that it is not strictly decreasing, it is decreasing only. That is, b should be greater than equal to 1. What is the highest value of cos? Which is 1. So b should be greater than equal to 1, because b is greater than equal to cos, and cos has the highest value as 1. Now this is how we are going to write about it. And please remember, cos x should be between -1 and 1. This is the whole logic of this question. And since it is greater than cos x, highest value of cos x is 1. That is why it is greater than 1. Now show that the function fx equals to this one is an increasing function of R for all value of a. X plus cos x minus a. First we'll differentiate this. F dash x, it is 1 minus sin x. This is going to be 0. 1 minus sin x. So it is an increasing function. That is, 1 minus sin x should be greater than equal to 0. If it is greater than equal to, that is, it is increasing function. So this is how we write, because we have already differentiated it. 1 minus sin x should be greater than equal to 0. So sin x should be between what? Because I'm just taking 1 on other side, or you can say sin x on other side. So sin x is less than equal to 1 in this case. So what do we get? See, I've just changed the sign. Now both the sides, if you see, now there is a slight change. I'll do it here. 1 minus sin x is greater than equal to 0. So I'll just change this. I'm just changing it. Okay. Again, sin x between -1 and 1. This is the better way to approach to solve it. Sin x is between -1 and 1. Now what I'll do is, I'll multiply both sides by -1. When I multiply both sides by -1, what I'm going to get? The inequality signs will change. Less than equal to will be greater than equal to. This is minus 1. This is -1. Now this is, now add just 1, both sides, because we are in a process to get 1 minus sin x. So when you add 1, you'll get 1 minus sin x between 1 and 2. Now what is 1 and 2? They both are positive. Means there will be never this 1 minus sin x will get any number which is negative. So it is always greater than or equal to 0. I showed you. First I tried a different approach. Then I told you no. We should go to this approach. So 1 minus sin x is between 1 and 2. So f dash x is greater than equal to 0. Because 1 is greater than 0, 2 is greater than 0. So this is how we are going to write it. So we have different ways we can write. It can be straightforward. It can have all the symbols. And symbols are much appreciated in mathematics. Now this question is somewhat different. F is defined on 0 to 1. X is between 0 to 1 in all the options here. Twice differentiable is an important thing. So we have fx, we have f dash x, and we have f double dash x also. So twice differentiable such that this modulus of fx is less than equal to 1. Now if I do one differentiation, see fx is there. If I do the differentiation, what you are going to get? Both side differentiation if you do. Keep the modulus on, but differentiate it. It will be right side will be 0. So f dash x should be less than equal to 0. This is the thing which we have taken out from the question. So when the f dash and f double dash will come, you have to follow the Rolle's theorem and Lagrange's mean value theorem, because one more thing is given. f0 equals to f1, fa equal to fb, a is 0, b is 1. So fa equal to fb. So whenever it comes, then also it is f dash c is equal to 0. I am saying that in Rolle's theorem, we always do that. F dash c is equal to 0 if fa equal to fb and the function is differentiable and continuous also. So what do we write normally? What do we write? When we write, it is fb minus fa by b minus a equals to f dash c if we go ahead with the Lagrange's mean value theorem. So this is the relationship I wrote on the basis of Lagrange's mean value theorem. But I'm just changing c with d, you'll see right now. Now f double dash d is also given, f dash double d, it is twice differentiable. So this fb minus fa by b minus a equals to f dash c, I have double differentiated. I have changed c to d because we have already used c. And I told you already f dash c is 0 because it is already in the question. And I gave you 2 explanations for that. So f dash c is 0. So f dash x by x minus c equals to f double dash d. Now one more thing is given, f double dash d, this one. This is less than equal to 1. Double differentiable. So it is double differentiable. It is less than equal to 1. So this f double dash d is less than equal to 1. That means left side is also less than equal to 1. F dash x by x minus c is less than equal to 1. That means f dash x is less than equal to x minus c. But you tell me x and x is varying, c is varying because c is also belonging to 0 to 1. So what will be the highest value of x minus c and lowest value of x minus c? If you have 1 minus 1, it will be 0. Okay, if you have 0 minus 1, it will be minus 1. If you have 1 minus 0, it is going to be 1. So again, it will vary from negative 1 to 1. Alright. So it is less than equal to, and we are taking the modulus, that is we have to take the positive sign only. So we will take only 1. So this f dash c or x is less than. This f dash c or f dash x is less than 1. So f dash x less than 1. This is what we have to prove. So all this Rolle's theorem and the Lagrange mean value theorem is to be applied so that we get this f dash x should be less than 1. So you need to know these two in order to actually understand and solve this question. So this is the whole process of solving it. You can just follow this. And any problem, just let me know, because this is a very typical question. Find the interval in which this fx x into modulus x is increasing or decreasing. So modulus x is x if x is greater than or equal to 0. It is positive. If x is less than 0, then modulus x is going to be negative x. Now this case 1, case 2 we are going to take, one for the positive, one for the negative. And since we are talking about real number, we will take just 2 parts. One which is greater than 0, means 0 to infinite, and one which is less than 0. That is negative infinite to 0. So x is greater than or equal to 0, x is less than or equal to 0. So these two cases we have to take. When x is greater than or equal to 0, what are you going to get? Fx is x into, as I told you, modulus x will be positive here, x. So it will be x into x, that is x square. How about here? Fx will be what? X into modulus x. So x is less than 0. So we will take negative x here. So minus x square you will get. Now let us take the differentiation. F dash x now we are going to take. F dash x is what? 2x here. Here minus 2x here. So if till here we have taken both the cases and gone up to the same step. Now this x should be greater than or equal to 0, because case 1 we have specifically taken, we are talking about x greater than 0. So f dash x should be greater than 0. The 2x should be greater than 0, or it should be, take equality sign also. So x should be greater than or equal to 0 because we have divided both sides by 2 here. X is greater than or equal to 0. That is, we are talking about plus here. Now coming to this one. See, above 0 it is increasing. We have established that. Now x less than 0, what is going to get? We are going to get when x is less than 0. So this is just multiply both sides by negative half. The inequality sign will also change. So only x will remain. This minus 2 minus half will get cancelled. This 0 into something will 0. So x is less than 0. When you have x less than 0, one time I told you x is greater than or equal to 0 for x greater than 0, and for x less than 0, again x less than 0 we got. I hope you got the idea. That f dash x, see, the first case f dash x is greater than 0 when x is greater than or equal to 0. So on the right 0 to infinity it is increasing, and on left it is decreasing. So it is neither increasing nor decreasing. So there are two solutions which I can show you. Second one is a more compact one. Here directly we have differentiated and show that x greater than 0 or x less than 0. X greater than 0 is 0, it is increasing, otherwise it is decreasing. So increasing and decreasing both time, that is why it is neither increasing nor decreasing. Or you can say f is increasing for x belongs to R for these intervals. Find the interval in which this fx is increasing or decreasing, sin x plus modulus of sin x. We are talking about 0 to 2 pi. Now how to find out this sin x is going to be positive or not? This is add sugar to coffee, and we know which all places or in which all quadrants these are going to be positive or negative. So 0, pi by 2, pi, 3 pi by 2 and 2 pi. So this is where we go the anti-clockwise direction. Now if you take first quadrant and second quadrant, sign will be positive. So case 1 will take, we are going to take 0 to pi, the first part. And between 0 to pi it is positive. Case 2 will take x belongs to pi to 2 pi. So we are going to the clockwise direction below the that is the negative y axis. So f dash x now we are taking, we are just taking fx right now. So what is modulus of sin x? I told you between 0 and pi it's going to be positive sin x, but between pi and 2 pi it is going to be negative sin x. I hope you got the idea. So when we are talking about 0 to pi, we will take sin x only, modulus of sin x will be sin x only. So it will be 2 sin x. But here when we take fx equals to, because we are talking about pi and 2 pi, in between this is going to be negative sin x. So negative sin x minus sin x. So the right part of the case 2, between pi and 2 pi it is going to be 0. If you take the differentiation it will be 0. So f dash x should be greater than or equal to 0. You are getting 0. So it is increasing here. The logic wise it is increasing because it is greater than or equal to 0. So equal to we have got. Let us come back to the left side. So let us take differentiation here. So this 2 cos x. So f dash should be greater than 0. This is only possible when we have 2 cos x equals to 0. So 2 cos x greater than 0 means if you divide both sides by 2, you will get cos x greater than 0. Cos x is greater than 0. Where do you get cos x greater than 0? Cos is positive here at first quadrant and the fourth quadrant. That is x should be between first quadrant and fourth quadrant. So 0 to pi by 2 it is increasing. It is negative here, it is negative here, it is positive. So this is between where? I am talking about positive right now because we cannot go beyond 0 to pi. Case 1 is only between 0 to pi. Please remember. So you cannot take 3 pi by 2 to 2 pi because it is out of the bound, because we have taken the case 1 as 0 to pi only. And the case second we have already got that f dash x is increasing. So x equals to 0 to pi by 2. It is increasing. And case 2 also we saw that it is greater than or equal to 0. Now 0 to pi by 2 it is increasing, but pi by 2 to pi it is decreasing. That is x belongs to pi by 2 to pi. Here it is 0 to pi by 2 it is increasing, pi by 2 to pi it is decreasing. Because cos is negative there. So one time it is increasing, one time it is decreasing between 0 and pi. So between 0 to pi, that is 0 to pi by 2 it is increasing, pi by 2 to pi it is decreasing. So it is neither increasing nor decreasing. What I am trying to say here is, this is 0, this is pi by 2, this is pi, this is 3 pi by 2 and this is 2 pi. So I told you between 0 to pi by 2 it is increasing. 0 pi by 2 to pi it is decreasing. Then pi to 2 pi as you got this f dash x which is 0, which is greater than or equal to 0. So it is increasing. So sometime it is increasing, sometime it is decreasing. So it means that between 0 and 2 pi, this function sin x plus mod sin x is neither increasing nor decreasing. So how are we going to write it? This is the whole procedure we are going to write it. Alright. And please do remember to make the diagram. That by diagram will make it easier. Find the interval in which the following this thing is increasing, decreasing between 0 and pi by 2. First we'll do the differentiation here. What will be the differentiation? F dash x. This is sin x. Now let us differentiate 1 plus cos x. It is going to be minus, cos x is minus sin x. Now 1 plus cos x you can write just like this. Differentiation of sin x will be cos x. So this is going to be minus sin square x. Now multiply this 1 plus cos x with cos x. So cos x plus cos square x. Now this sin square x you can write it as, because sin square plus cos square is 1. So sin square will be 1 minus cos square. You have a negative here, so multiply with negative. It will be cos square minus 1. Now just write it here. Cos square minus 1 plus cos x plus cos square. So 2 cos square x plus cos x minus 1. Now 2 cos square x plus cos minus 1. This is a perfect square. No, we can take the factor now because it is not a perfect square. 2x square, I am saying x is cos x. So let us make this as 2x square plus x minus 1. We will replace x by cos x just now. So this 2x square plus 2x minus x minus 1. You can take 2 common here, 2x common here. You will get x plus 1 here. You can take minus 1 common here, x plus 1 here. So you have 2x minus 1 and x plus 1. These are the two things. So what are you going to get? See, this is f dash x we have found out. So this, in order to increase this, first let me write the factors here. 2 cos x minus 1 and x plus 1. So I am taking case 1 where f dash x should be greater than equal to 0 or greater than 0. So greater than 0 means both should be positive or both should be negative. So even if you take both positive or both negative, you are going to end up with the same solution. Same scenario you are going to get. That means 2 cos x minus 1 should be greater than 0 and x plus 1 should be greater than 0. This x is actually cos x. So let me replace it by cos x. So cos x plus 1 is greater than 0. So from here you get cos x is greater than half, and here you will get cos x should be greater than minus 1 because it is cos x plus 1 greater than minus 1. So cos x is greater than half. Cos x value vary from where to where? It is minus 1 to 1. So if it is greater than 0, it has to go from half to 1. So cos 0 is 0, cos pi by 3 is half. So the highest number is 1. So you have to start from pi by 3 and go up to 0. That is 0 to pi by 3 is the range where cos x is greater than half. Coming to the right one, cos x is greater than minus 1. It has to be between 0 to pi by 2 because cos 0 is 1 or cos pi by 2 is what? 0. So you are going to go above minus 1. That is only possible when you are going from 0 to 1. Because as I said, cos x is always between negative 1 and 0. So you are talking about 0 to 1. Say this cos x is greater than minus 1. That is the angle is 0 to pi by 2. You are here. So we have two parts here. And these two parts are saying what? See here. This is 0, pi by 3. This is pi by 2. So this is 0 to pi by 3. This range we are talking about. Second range is saying 0 to pi by 2. And we have to take the intersection because they both are going to give one solution. So this is the common part 0 to pi by 3. So x is between 0 to pi by 3 where this function is going to get increment or it is increasing. First part is over. Now let us come to the second part, which is f dash x should be less than 0. Same thing, 2 cos x. If you remember just now, 2 cos x minus 1 and cos x plus 1 should be less than 0. So in less than 0, 1 can be positive, 1 can be negative, and vice versa or otherwise. So you can take 1 as positive, 1 as negative or the otherwise, because the answer is going to come same because the interval we have to find out. So I'm taking the second case. So 2 cos x minus 1 should be less than 0 and cos x plus 1 should be greater than 0. And here I already told you cos x was greater than minus 1 and you know the range was or the interval was 0 to pi by 2. This we have established just now. Just now we have established. So cos x here is less than half. So I just told you cos x is less than half means 0 to pi by 3 I told you. We are talking about 0 to pi by 2 here. So if I make this line 0 to pi by 3 and pi by 2. So this is saying cos x is greater than half. We are talking about this range. Cos less than half means it was pi by 3 to pi by 2. So cos x greater than half I just told you in the previous just a few moments ago. But cos x less than half means we are talking about this one, pi by 3 and pi by 2, because cos pi by 2 is 0 and cos pi by 3 is half. So x should belong to pi by 3 and pi by 2. And what about here? Again number line. So we are talking about 0, pi by 3, pi by 2. So pi by 3, pi by 2 here. The first solution is this one. Second solution is what? 0 to pi by 2. This is 1. And what is the common one? Which is pi by 3 to pi by 2. So x belongs to pi by 3 to pi by 2, where this function is doing the decrement, decreasing. First one was x belongs to 0 to pi by 3, and the second part of the question we got, it's this one. So this is the solution and this is the reference you can follow to solve it. It's not very tricky, only the angles you should know, and in NCERT it has already come many a times. Okay, thank you so much. This 17.2 is finished now. Take care.